My name is Dmitry. I'm a software engineer and a Python and C++ mentor. This is the fourth video in a series that I'm making about how to define strict JSON config schemas in Python using Pydantic v2. So if you haven't watched the previous three videos, I would highly recommend you watching them first to get you up to speed for what we're going to be talking about in this one. Here, to kind of quickly remind ourselves where we left off, on the left, I have a Python, some Python code that implements a VPN client that has destination server and destination port. And it also supports something that we have added in the previous video, encryption, two encryption methods, crypt_foo and crypt_bar, crypt_foo requiring a password and crypt_bar requiring a key. Now, on the left, we have the naive approach to implementing such configuration and reading it from JSON. And in the previous video, I have highlighted some of the issues that we have faced with that solution. So I'm going to quickly showcase those issues to you so that we know what we're going to be fixing. Yeah, so dict app will run on a config that I have shown you last time. So this is a valid config that we can kind of take a look at. So this is a valid config using crypt_foo. It has a password. Now, a second config is going to be a valid one using crypt_bar. It has a key, and we can run on it as well. So we see the crypt_bar specified, password is none, that's fine, and the key is specified, that's good. Now, the two issues that I have been talking about can be highlighted by the two following configs. So the first one is going to be the bad config. Bad config is bad because it uses crypt_foo, but it doesn't specify any sort of password. And crypt_foo, as we know, cannot work without a password. So, but the problem is that when we run our application on that bad config, it doesn't fail in any way or doesn't designate an issue in any way. It just accepts everything it's been passed and just populates it in the VPN client, which now has this broken config. It has the method crypt_foo, but the password is none. And the other issue that we have discussed can actually be highlighted by this other config that I have called confusing config. Here, the issue is that the key that we have specified here does not lead to the application failing, even though, since we use crypt_foo method and have the password specified, password is really all we need for crypt_foo to work, so the key is really not necessary. And in the last video, we have discussed why is that a problem and why we should kind of try to fix it. So I promised to you to fix it using Pydantic v2, and here we are. So let me quickly switch to my second window in Tmux. Here we go. Now, here we have two files of Python code that actually implement the same kind of thing, but using Pydantic. Since the code base got a bit larger, I decided to split it in two files, just for clarity's sake. So I will explain to you a concept from Pydantic that we can use here to solve this issue entirely. So the concept itself is called discriminated unions. It is based on an understanding or on a concept of unions that is present in Python, but not only in Python. It's also a thing in C, C++, and generally in programming. So union in Python specifically, that is kind of a type annotation that goes along with some list of types. Python actually requires it to be more than one, cannot be one, has to be at least two. Yeah, and the idea of that type annotation is that if your field or property or object is of type of union of a list of other types, in practice, that means that this thing is going to be of one of the types from that list. So in here, we have crypt_foo config and crypt_bar config listed after the union. That means that anything is, for a thing to be of the type union of those two types, it has to be either of the type crypt_foo config or of the type crypt_bar config. So that's the general concept of a union when a thing is of one of the types from the list. And that actually resembles and is very relevant for what we are trying to do here with the encryption methods that we are trying to implement in our application, right? Because we have two methods, crypt_foo and crypt_bar, and their layouts, their configs are different. And so it makes sense to create two separate models, one for the config for crypt_foo, and the other one is for config for crypt_bar. And then the actual thing that we will be specifying in the application config will be a union of those two models, because it in practice can be any one of those two. So Pydantic does allow a field on the Pydantic model to be of the type union. So in here, what we have on the left, I'll walk you through the code on the left in a second. But the idea is that to be using those unions, you have to specify, or you have to define Pydantic models that you're going to be uniting, kind of, and then you specify it as a field on another Pydantic model. So let's go from the top to bottom to kind of explain what is happening here. So first of all, we have strict base model. That is actually kind of a trick that allows me to avoid specifying the same model config on all the Pydantic models that I'm defining in this file. The way it works is we create a class, strict base model, although the name can be anything, and we derive it from the Pydantic base model, and then we specify some model config that we would like to use in multiple Pydantic models that we're defining in this file. Having specified this model config, now we can define other Pydantic models by inheriting not from the base model from Pydantic, but from our strict base model that we've got here. What it gives us is, well, it's kind of two things packaged. First of all, it's going to inherit from Pydantic base model because the inheritance is transitive in Python. And the second thing it's going to give us is it's going to inherit the model config as well. So if we don't want to change that config and we want to use the same config in multiple Pydantic models that we're defining in this file, we can do so by putting that model config under one strict base model and then inheriting all the Pydantic models from that one class. Now, for the following two classes are actually Pydantic models for the two types of encryption that we're going to be implementing. The first one is crypt_foo config. The name is very much corresponding to what it tries to resemble. It has the method crypt_foo, so method field that is of the type literal crypt_foo. So the literal type annotation means that the only thing that this field can be equal to is crypt_foo. And the password is just a string that we have to specify if we're using crypt_foo. Now, for crypt_bar config, we have the method called field that is literal crypt_bar, which means it can only be crypt_bar, and the key field that is also a string that also has to be specified if we're using crypt_bar config, because it doesn't say, like, doesn't specify default value or anything, so it by defaults to being required by Pydantic. And now the VPN client config very much resembles what we had in the previous videos, except it adds one more field, which is an encryption. And this field, well, it's kind of a big one. So let me kind of unwind what all of those statements mean and do in this piece of code. So on the very top or outermost layer, we have something called annotated. This is just an annotation in Python that allows you to attach multiple other annotations to the same field all at once. So here we just use it to attach both the type annotation here and the field annotation from Pydantic. So the type annotation is actually the union of two of the models that we have defined above. So that's what we have already talked about a bit. And now comes the interesting part where we actually attach the field annotation that has two properties. One of them is description. We have seen that a lot already. But it doesn't actually affect the Pydantic runtime all that much, or at all, to be frank. But the discriminator part is actually something very relevant. Let me try to explain it to you what this discriminator field means and does. So if you think about it, if you were to try to implement the logic from Pydantic, parsing a destination server field is very simple, right? It says it's supposed to be destination server, it is required, and its type is string. So what you would need to do to verify that, say, a Python dictionary conforms to a VPN client config that would only have this destination server is just verify that the only property or the only key it has, that the dictionary has, is a destination server, and that its value is actually a string. And that's it. So that's the end of your validation. Very simple. Same kind of goes for destination port with the slight difference that the type is integer and it also is allowed to be missing. So it's basically, if it's missing, it's fine. If it's not missing, then it has to be integer. But like anything that matches that will work. Now, the actual union that we've got here is a bit more subtle, a bit more sophisticated. Why is that? Well, it's not immediately clear to Pydantic which one of the two, in this case, or arbitrary number in general case, models to try to match the Python dictionary against. Yeah, so it's kind of clear if the Python dictionary doesn't match any of the models listed in that list, then it's just going to fail the validation because it's clear that it cannot conform to the union type because it doesn't match any of the models. But now, having some set of models that you can specify here, in some cases, it is possible for the same Python dictionary to kind of match multiple models from the list. But then Pydantic has to choose one of them. It cannot stick with multiple. So that kind of presents a problem for Pydantic. And actually, Pydantic employs a number of strategies for choosing which model to use. And discriminated unions is one of those strategies. Discriminated unions is, in my opinion, the most clear and the simplest to use and the reason about model or tactic that you can use for implementing and using unions in Pydantic. So the idea is that you specify something called the discriminator field. In this case, it's a method, and it's actually going to be a string that is going to represent a name of the field on the models that the field is union of, that Pydantic is going to try to use to figure out which of the Pydantic models to match the value of that field against. So here we only have two models, and it's not a coincidence that both of them have this method field because I intended it to be that way. And since I'm using the literal type, it basically tells Pydantic what type I'm expecting to have here. So it knows that crypt_foo config is supposed to have crypt_foo as its method, and crypt_bar config is supposed to have crypt_bar as its method. And now, when I tell it that the discriminator field is method, it knows that when parsing the encryption property of the config, it's gonna first look at the value of the method field in the dictionary. If the method field is not present, then it's just gonna fail validation. So it's not gonna accept that config and reject it and fail. And rightfully so, because we expect every config to be using one of the two methods and to explicitly specify which one of the two methods they are using. Now, if the method field is present in the dictionary, what it's going to do is it's going to look at the value of that field and try to compare it to one of the literal type annotations that it has in the Pydantic models that the field is union of. So this is a union of crypt_foo config and crypt_bar config. So it's going to look at both of them. it's gonna fetch the crypt foo and crypt bar values, which are the expected values for the methods to those classes correspondingly. And if the method value in the dictionary is one of those two values, so one of the crypt foo and crypt bar, then Pydantic is going to use the corresponding Pydantic model for validating that dictionary. If it's neither of those two, then it's going to fail validation because, again, there's no chance that this Python dictionary is going to be a union of those two models because it clearly mismatches both of them, so can't be a match to one of them. Yeah, so that kind of concludes the explanation of what a discriminated union is. I actually really love them because they allow you to write a model structure that matches the domain structure that you're trying to encapsulate exactly. So in this case, both you and I know that cryptfoo has to have a password. And here we say, yes, cryptfoo has to have a password. Cryptbar has to have a key. Yes, cryptbar has to have a key. Now, VPN client config is supposed to be using either cryptfoo or cryptbar. Perfect. That's exactly what we say by this line. So it kind of puts the description of the logic into the code, and it also makes sure that the code will verify that the config model, config structure corresponds to the model that we have encapsulated in this code exactly. Now, the piece of code in the middle, the one that actually uses those models, is actually pretty simple and is kind of the same thing that we had before, right? So it just imports the three models. That's the difference. Then we have the same function for reading, JSON. VPN client this time around is just accepting a VPN client config and is just storing it and then printing some of the values. Pay attention to something interesting here. So the destination server and port are printed regardless, right? Because they are present in the config regardless. The method for the encryption is also present in all of them, but then we only print the password if the encryption type is cryptfoo, and we only print the key if the encryption type is bar. So that again is documenting the logic and the structure of the domain very well. And now we can actually go ahead and kind of run this thing. So let's first of all look at the config that I'm going to run this on. So the config one, note that I'm not actually using the exact same config that we had in the previous video, but it's structurally, or rather functionally, the same. The only difference is that we had to lift the method and password fields one level up and put them under the encryption property, because this is what we define in the model, and it kind of makes a lot of sense, right? So it introduces the kind of separation of concerns. It separates the encryption information from the rest of it. So that's good. So this is the config one, which is almost exactly the same as the config one that we used in the previous video. Now we run Pydantic app against that Pydantic config one. And what we see here is exactly what we would like to see, which is bettersoftware.com, 1234, and then cryptfoo and password admin 123. Note that we are not even printing the key because the key cannot exist if the method is cryptfoo. Now we have similar example of a config for cryptbar, and we can also run it. Here we run it, and that's something that we love to see. We see method cryptbar and the key, but the password is just not present. Again, very nice. Now let's touch on the configs that we deemed as problems in the previous video and see that we have actually fixed them. So the first thing we're gonna look at is the bad config. So here, again, I tried to resemble the broken config from last time as close as I could, but I rightfully so lifted the method cryptfoo into the encryption property, but that doesn't salvage this config because it is still very broken. So if we try to run this thing, app, Pydantic bad config. This fails. Let me enlarge this right tab for you so that we can read the text. And it actually says that one validation error for VPN client config. And the error is, it says that the password is missing, right? Field required, type missing. So that's exactly what is happening here. And this happened immediately. So we failed early, just like we should have. Now, the other type of problematic config that we have touched on the last time was this confusing config.json. And yeah, so I have, again, changed the structure a tiny bit so that it resembles, so that it is ingested by our code or has a chance to be ingested by our code, but it's actually not going to be ingested because it's going to realize that the config is actually broken. So it says, yeah, in here it says that the inputs are, extra inputs are not permitted. And it says that the key is an extra input. So yeah, that's exactly what we would expect this code to do, which is, yeah, how you fix that issue using Pydantic v2. So now in the next video, I'm going to actually show you how having such a strict type schema here that resembles the config schema is going to help us write some of the other, or like the rest of the code, the actual functionality of the class in a better way that is going to resemble and that is going to make sense a bit more. So I will show you some problems and how we fix them. Please stay tuned.